Thank you very much indeed, Joe, and thank you to Declan for inviting me here, and Sandra Galvin and Iain Broder for helping me get here. It's been one of the most tweeted meetings that I've ever come across, actually. The first speaker after lunch knows that you're allowed to go to sleep during my talk. But I urge you, in fact, I will tell you when I've finished, because you need to wake up and listen to what Caroline Hurley, Aislinn Conway, Jessica O'Dowd, Lydia Emerson, and Marina Zaki have got to say in the presentations which follow mine. They will be worth listening to. Marina, I think your surname means delicious, doesn't it? Zaki, Mishek. Anyway, as you'll see from this, I don't know if it's possible to take some of the light off these screens. It might make it easier for you to see some of the things that are on it. I don't know, for example, that curtain there. As you see, I'm going to be talking about the James Lind Library and some illustrations from it showing the evolution of fair tests of treatment. And I should mention that Mike Clark, whom all of you know from earlier today, is one of my co-editors in the James Lind Library, together with another young person, Douglas Badenoch, and another old person, the same age as me, in fact, Ulrich Dröller, who's Swiss. So we're the band that put this database together and invite people to write for it and to add things to it. Now, fair tests of treatment can be very simple. If you take, for example, these examples of situations where randomized trials, for example, are really unnecessary, it's when you get a dramatic effect, and a big one. And that first one, where you've got an unchanging condition, then you do something, and it goes down to a new unchanging condition, we illustrated in the paper by the example of the mother's kiss. Now, put up your hands if you've not heard what the mother's kiss is used for in medicine. Good, so quite a lot of you know. It was brought to my attention by Paul Glasziou, who was the first author of this paper, as you see, a general practitioner who, on one occasion, was brought a toddler by the toddler's mother, who had put a bead up the toddler's, one of the toddler's nostrils. And he asked the nurse to go and get some forceps so that he could try to remove the bead, because he knew that if he wasn't able to do that, almost certainly the child would have to be anesthetized and have it done under general anesthetic, taken out under general anesthetic. And so the nurse said, well, had you thought of trying the mother's kiss technique? And now you'll probably start, those of you who hadn't heard of it, will start to guess what it involves. Basically, the mother presses on and blocks up the unblocked nostril and blows into the child's mouth. Out pops the bead. Now, you don't need carefully controlled trials to show that that is an effective treatment. You may need to do case series to find out how often it fails, or if there are different ways of kissing, it may be that you'd need controlled trials to show the difference between the different ways. But that's a really dramatic treatment, and all of us know lots of them. But putting a tourniquet on an arm where there's arterial bleeding spouting out from an injury. There are lots of examples. So don't let's kid ourselves that those people who say that randomized controlled trials are the only basis for working out whether treatments work or not are doing anything other than actually displaying their ignorance. And it's actually not good for making the case for carefully controlled trials to make that sort of statement. Okay. Back in 1998, it was 50 years since the publication of a very famous controlled trial in the BMJ. It was a trial to look at the effect of giving streptomycin and bed rest versus bed rest alone to people who had got pulmonary tuberculosis, from which people used to recover, but they also used to die. So it wasn't as if it was going to give a dramatic effect, which it does in tuberculous meningitis with this new drug, but we wanted to get some, they wanted to get some indication of how effective this would be. Now, it's an iconic trial, and probably the reason it became iconic was that there was a description in what was an extremely competent write-up that the allocation was made by reference to a statistical series based on random sampling numbers drawn for each sex at each centre by Professor Bradford Hill, the father of trials methodology in this, nearly made a mistake, in Britain. And people were struck by that. So the history, the standard historiography goes like this. Here's one from a French philosopher, historian. The first real trial, randomized trial, was the trial of streptomycin in tuberculosis, organized by the MRC under the responsibility of Austin Bradford Hill. This trial applied in the medical field, the principles of experimentation developed by Fisher in agriculture. Here's another historian. The professional emergence of statistics as a codified body of knowledge and the concomitant rise of individuals trained in its methods provided the necessary conditions for the Laplacian version of the probabilistically based clinical trial to come into being. What a sentence. Harry Marks. The randomized clinical trial is an extension of the statistician R.A. Fisher's ideas about experimental design. The statistician's randomized controlled trial came to represent the symbol and substance of the statistical method in medicine. Jean-Paul Godelier. The history of randomized clinical trials may be traced back to the biometrician's work. There was a direct lineage from Pearson to Bradford Hill via Fisher and Major Greenwood. The basic concepts grounding the choice of randomization can be traced back to R.A. Fisher's work. Iain Magnello, who was herself a statistician as well as a historian. Carl Pearson's 1904 proposal for a clinical trial using alternation to generate comparison groups. A seminal statistical idea. Pearson's statistical methods provided the framework for Bradford Hill's work on the randomized clinical trial. Well, they're wrong. And here I want to introduce you to an alternative historiography which should have been recognized by Iain Magnello from the quote I just gave you. It's not a seminal statistical idea to create unbiased treatment comparison groups. It was rooted in the much older idea that fair test of treatments involve comparing like with like. Clearly, if you have patients who are on average rather iller in one group than in another group, and you give them different treatments, you won't know from their progress whether any difference that you observe, or come to that, any similarity, is due to the treatments or is due to the fact that they started off being incomparable. So back in 2003, in a presentation to a bunch of medical historians, I went in some trepidation to give a paper with that title. And what was nice, this was, as you see, a long time ago, what was nice was that the people there felt that I had made the case that it wasn't a statistical idea. It was one which came from within medicine. So here's a controlled trial done in 1809, written up in Latin as part of an MD thesis for the Edinburgh degree of MD, to assess the effects of bloodletting on camp fever on mortality. There's the title page of the thesis. The author was Alexander Lasassier Hamilton, who was an army surgeon at the time. The base camp hospital was in Portugal, and I'll tell you what he did in a moment, but you want to know why this book is called The Most Beautiful Man in Existence. That's how he described himself. And Lisa Rosner, who's written up this biography, subtitles it The Scandalous Life of Alexander Lassassier. And indeed, he cheated on his wife, he was always in debt. But there is an interesting side to him. He's obsessional. When he goes to a new place, he goes to the local public library to find out what books there are. He was very good at filling in the returns of sick people treated and so on. So on one occasion, he, and this is recorded in his MD thesis, it had been so arranged that 366 soldiers with fever were admitted alternately in such a manner that each of us, there were 3 surgeons, had 1/3 of the whole. One of the surgeons used bloodletting, the other 2 didn't. The sick were indiscriminately received, avoiding bias, and were attended as nearly as possible with the same care and accommodated with the same comforts. In other words, holding these other factors standard. Neither Mr. Anderson nor I ever once employed the lancet. He lost 2, I 4 cases, and that gives a mortality of 2.5%, whilst out of the other third, treated with bloodletting by the 3rd surgeon, 35 patients died, a mortality 10 times as high. Now, what was happening in Dublin at that time? Well, you'll see in a moment, but there was a report, and it was produced by Thomas Mills. And you'll see the bit on the left-hand side of the slide, you can see it's Dublin, although it's rather beautifully written. And I don't know whether Cork Street still exists in Dublin, but that was one of the places where there was a fever hospital. And then there was the St. George's Dispensary, which was a place where these patients were recruited. And as you see, they had fevers associated with a whole lot of different things, and some of them died. He had incredible tables in this book. These are just 2 pages from lots of very, very detailed tables. And he was right in concluding that the number of cases he had were probably sufficient to show the effects of bleeding and fever. The trouble is, he assumed that the relatively few people who died suggested that the treatment was safe, because he refers to the good effects. Of the 504 patients blooded from the 15th of May to the 1st of January, 18 died. This makes the proportion of the deaths of the recoveries as 1 to 28. So he even presented a statistic. But probably, if he had read the trial that I've just shown you, 1 or none of those patients would have died. So it just shows how, standard treatments can be in place for an awful long time. And in Dublin, he was clearly a very, very enthusiastic bleeder, venisectionist, but didn't do the people in the fever hospitals in Dublin much good. Right, here's a controlled trial done in 1854 to test claims that belladonna would protect children from developing scarlet fever during an epidemic. It was done by this man, who went on to become, he's medically qualified, he was an army surgeon, but he went on to become president of the Royal Statistical Society. There were 151 boys of whom I had tolerably satisfactory evidence that they had not had scarlatina, not had scarlet fever. So he started off by making sure that they were at risk of getting scarlet fever. I divided them into 2 sections, taking them alternately from the list. And here's the key phrase: to prevent the imputation of selection. He describes why he's using alternation. He wants to compare like with like. So by the beginning of the 20th century, that was halfway through the 19th, alternation for controlled trials became referred to formally as the alternative methode, la méthode alternante, the alternate case method, rational alternation, the alternate case method, simultan methode. And so this idea of alternation had nothing to do with statistical theory, nothing to do with Fisher, nothing to do with all of those ideas that I showed on the earlier slides. This was something which, in some senses, comes from common sense. Primary school kids know that if the teacher chooses children for different teams, she'll often use some equivalent to a chance process to have teams which are reasonably alike in their abilities. So it's common knowledge. It doesn't need some fancy idea of random allocation, which actually is quite difficult for people to grasp, to get accepted as a correct way of going about things. And so when you look at, remember 1948 was the date of the streptomycin trial. If you look for examples of alternate allocation in trials, you find quite a lot of them, and this slide's out of date. I came across some others in the Indian Medical Journal earlier this week, treatments for malaria, where alternation was being used. During 1926, the reports were published. And if you're looking for a place where controlled trials started, I think there are two places. India certainly deserves credit. The two people who made the greatest contribution there were Valdemar Haffkine, who was a Russian working in India, particularly on plague, but also on cholera, and Nasawanji Choksi, who was a Parsi with a very handsome hat. And here's Haffkine saying, and these I think were cholera patients, after all the people eligible were seated, every second man, without further distinction, was inoculated with the serum. The even numbers, the inoculated, were left to live with the uninoculated under conditions identical with those which they were living before. And here's Choksi, this one's for plague. The cases were to be taken for treatment alternately, his emphasis, in the order of admission, and his emphasis without any attempt at exclusion of any sort. So can you get the what's being proposed here by these early medical investigators? Well, fairly early medical investigators. They're not depending on reading books of statistics. And by the way, I have to say that I note there are quite a lot of statisticians during the presentations here today, and I'm very grateful when they get involved in health services research. When I started my time in Cardiff, I went to a Department of Medical Statistics, and I was introduced to the statistician who was going to work with me on a big data set there. And I had to admit to him that I had left a calculus class at the age of 15 in tears, never to return, and I was really not very numerate. And he'd said a very reassuring thing, which some of you, if you're anywhere near like me, might want to remember. Statistical ability and mathematical ability is a congenital abnormality. Most people don't have it. So I thought that was very kind of him. The other country that deserves credit is the United States of America. Very important progress was made in developing and analyzing controlled clinical trials from very early on the last century. And we should be grateful to Scott Podolsky, a doctor in Harvard, who's written up the history of these trials, the serum treatment, basically, of lobar pneumonia. And here's just a list of the alternate allocation trials that were done between 1912 and 1933. As you can see, there's lots of them. I've highlighted Jesse Bulwer's name because he was the most exceptional of the methodologists working in this group of trials. So first of all, they had large numbers, and they were allocated by alternation. So here's one example, 1,161 cases. The alternate case method was used. And they started to assess the likelihood that chance might explain the differences observed. So down the bottom of here, this is Bulwer's work. The ratio of the difference in the results of treatment must be twice the standard error. And they started to appear in the reports that were published from these trials. But they also did meta-analysis. Here's a study, 1928, showing that three different hospitals had done separate trials on serum treatment for pneumonia, and I've outlined in red the meta-analysis that was done based on the individual results from those three hospitals. So meta-analysis, the word, wasn't introduced until 1976 by an American psychologist, educational psychologist called Gene Glass. But the idea of saying, well, look, we've done a whole lot of similar trials, why don't we actually analyze them all together and see whether we pick up a signal from looking at them all together that we would miss if we looked at one of them one at a time. The UK, well, basically it was a bit of a disaster. There was something called the MRC Therapeutic Trials Committee, and as Ben Toth has pointed out, it didn't organize one rigorous comparative clinical trial, despite prima facie evidence of the problems of not doing so. They just ignored the things that could have been learned from both India and from America. And indeed, a historian, Linda Bryder, very nice Kiwi historian, had written a book in 1989 which had suggested that Therapeutics Trials Committee was really rather good, but she came to the conclusion that she got it wrong because they hadn't asked the question clearly enough about what actually did they achieve. They achieved more or less nothing. Their way of testing treatments was to get a few enough drugs for one or two patients, and to give them to their friends in clinical medicine, ask them to give it a go, tell us what you think of it. Very, very primitive. Except in one place, in Glasgow. These people did alternate allocation trials of sulfonamides. And they state at the end of some of their reports that it was a report to the Therapeutic Trials Committee. But they seem to have been completely ignored by the Therapeutic Trials Committee itself. Possibly because it was stuffed with medical research physiologists. They were basic science people, basically. They didn't understand about clinical research. And that's still a problem today, I would say, in some of the granting bodies. The wrong people are judging the quality of proposals for applied research. So we come to the MRC's first multicentre clinical trial. I've called it a bit of a shambles because it was. They were meant to use alternate allocation in this, but it broke down. And Bradford Hill wrote a confidential internal report, which unfortunately seems to have been mislaid, saying that the division of cases greater effort should be taken, that the division of cases really did ensure a random selection. And the second secretary of the MRC deemed Bradford Hill's memo so damning that it was to be kept not only from public scrutiny, but even from the investigators themselves. So they were also pretty ashamed of this shambles which they had presided over. But it was important. it showed Bradford Hill that these things had to be designed far more carefully and monitored far more carefully than was the case during this era of British medical history. He published a book in 1937, which, or rather the Lancet published his book, which was based on a series of articles in the Lancet. Bradford Hill is a wonderful writer, was a wonderful writer. He died some time ago. And he communicated with doctors very effectively. Some people thought that he was a doctor, that he was medically qualified, because he used to read up on the topics which he'd been asked to, which he'd been consulted about as a statistician. And he would be able to take part in the conversations that went on about the clinical aspects. But even he, and he described it later as because he thought random allotments were a rather difficult concept to get ordinary human beings to grasp. So he actually suggested alternate cases and referred to them as reducing bias, but he also in the same paragraph referred to it as random allotment. And all of you know that alternation is not random allocation. It's alternation, it's systematic. So, 1937, he says, you get reasonably large numbers, and then by a random division of the patients, the first being given treatment A, the second being orthodoxly treated and serving as a control, the third being given treatment A, the fourth serving as a control. Is that randomization? Is it randomization? No. And that's why he says no departure from this rule being allowed. That's alternation. It's not a random division. It's foreknowledge of the treatment allocations among those deciding whether or not to enter patients into a treatment comparison that often leads to biased allocation. Because if you know where the next, which treatment group the next patient is going to be assigned to, and she's your Auntie Doris, and she's very frail at the moment, and this new treatment seems to be possibly useful but really quite nasty, then you hold back until the next allocation and you put her into the standard treatment group or whatever. That's just one caricature of the sort of ways in which you can get biased allocation if you know what the next treatment is going to be. So you've got to conceal the allocation schedule. You've got to conceal it so that people who are inviting people to participate in trials and who said yes, they would like to, neither of them must know which treatment they're going to be allocated to. And that means you've got to be honest with them. The reason we're doing this trial is we don't know which of these treatments is preferable. We do know that half of our good ideas will turn out not to be good ideas. So when you're faced with uncertainty, this is a very proper and ethical way to behave if you want to protect patients. First decent trial done by the MRC was a trial of PATULIN. As you see, it was done during the Second World War, which is an antibiotic, which it's a mold which grows on apples in the treatment of the common cold. And it was thought very appropriate that this be tested, because if it did have an effect on the common cold, it would reduce sick leave for people who were needed for the war effort. And Mike Clark has written an extremely nice article in the James Lynn Library about this particular trial. But here's a summary of the thing. It was Philip Darcy Hart who was in charge of it. He was the head of the MRC's tuberculosis unit. That picture was taken when he was 104, when I was interviewing him. And Joan Faulkner was the field worker. Many of you will know the name Richard Doll. Joan Faulkner was Richard Doll's wife, subsequently. So here's some passages from the report. The medical officer remained ignorant of which test solutions the patient received, and neither the medical officer nor the nurse knew which contained PATULIN. The nurse gave out the test solutions in strict rotation. Now, rotation sounds a bit like alternation, but it's in fact when you've got more than, like Lasassier Hamilton did in his camp, in his army camp. He talks about rotation among the 3 surgeons. So this was actually a rotation among 4 groups, and it's interesting to see what they did. They used 2 PATULIN groups and 2 placebo groups. Everyone had thought we'd use alternation. We thought we were very clever in setting up a scheme with 2 PATULIN groups and 2 placebo groups. I don't know of another trial that's done this. Using letters to designate each of the 4 groups, then using rotation to allocate people to the different groups. We thought we were doing something completely new. We wanted to muddle people up. In fact, we succeeded in muddling ourselves up. We didn't always remember what the letters stood for. None of us was a statistician, but we felt that the PATULIN trial was the first decently controlled trial the MRC had done. And I think Mike, is Mike somewhere here? No, he's heard this before. Would you agree with that? The first decently controlled trial that the MRC had done?
Yes.
Yeah.
Well, I'm not going to say no, am I?
Well, you've written the article on it.
I would agree.
So, going back to this iconic report, why were random sampling numbers used? It was basically to muddle people up. The team responsible for designing that trial, the streptomycin trial, consisted of Philip Darcy Hart, looking a bit younger than he was when I took his picture at the age of 104, Mark Daniels, who was the field worker, spectacular researcher who unfortunately died from primary liver cancer when in his 30s, and Austin Bradford Hill. So this is the key thing about that study. The details of the series were unknown to any of the investigators or to the coordinator, and were contained in a set of sealed envelopes, each bearing on the outside only the name and the hospital and a number. And as you know, people came to know that if you held up an envelope in front of a projector light, for example, you could sometimes cheat on this. So people had to be really devious to do that, but it meant that if the randomization leaks, the trial goes down the drain. Richard Dole said randomization was introduced to control selection bias, not for any esoteric statistical reason. And David Cox, one of the most distinguished living statisticians, said, although there are statistical reasons for random allocations, the most important function is to help achieve concealment of an unbiased allocation schedule and thus avoid selection bias in the creation of comparison groups. So that's the historical importance of the streptomycin trial and the PATULIN trial, which has to be given credit as well. Concealed random allocation makes it difficult to cheat. Subsequent international recognition of the MRC's role in developing the science of clinical trials became really quite a thing. Bradford Hill was invited over to Harvard to give an important lecture there on the clinical trial. Beautiful article, beautifully written. And look at the trials that they did during the first 2 decades after that time in lots of different conditions. Those are just to give you some to look over briefly. And then here for the second decade. It's a fantastic record. It was a blossoming of randomized controlled trials on a variety of different topics, which helped to usher in the randomized trial as a method into medical research. And the people that in some senses deserved credit for this were sometimes they were statisticians, sometimes they were medically qualified. So for example, Bradford Hill, Armitage and Ian Sutherland were all statisticians. Dole, Nolden and Reed were all medically qualified, but very numerate, very statistically savvy. And that group of people were asked to, by the Council for International Organizations of Medical Sciences, to organize a conference in Vienna in 1959 to tell people about what they had done over the previous decade. And they did. It was organized by Bradford Hill. It was the papers were available only in mimeographed, that means photocopied basically, version. But there was a demand for a printed, published version, and that was very rapidly translated into French. Just have a look over the things that were covered. Basically, they reflected those various areas that I showed you on the earlier slide. Including cancer and including surgery for cancer. This is Peter Armitage. He's the only living survivor from that group. He lives not far from Oxford. He's in his 90s now. He's an absolutely delightful man, and if anyone was ever one of his students, then they'll know just how delightful he was. Sheila Bird has written a nice article about that meeting in Vienna, which is on the James Lynn Library. So why doesn't the MRC celebrate its key role in the development and application of fair tested treatments? Why hasn't it commissioned a substantive biography of Bradford Hill? And why aren't there portraits of Darcy Hart and Bradford Hill and Mark Daniels on a British postage stamp? I don't know. I keep on trying to shame them by writing and saying these things. Answer comes then none. So that's the James Lynn Library, and you'll find lots of stuff. It was recently relaunched with a new design, which I wasn't responsible for it. So it was a company called Minovation that organized it. I think it's absolutely beautiful. So do have a look at it. And I just want to end by dedicating this lecture to two people who have contributed importantly to the history of controlled trials. Patricia Crowley is an obstetrician in this city. I would have loved to have seen her, but I've not been able to contact her. She did the systematic review and meta-analysis, which forms the basis of the Cochrane Collaborations logo. So she's contributed very importantly. Adrian Grant, together with Dermot MacDonald and others at the National Maternity Hospital in Holles Street, did a very big trial of fetal monitoring. 13,000 women contributed to it and established that there were methods of monitoring which would reduce the risk of seizures in newly born babies. And I put him there with some sadness because he died about a month ago. So thank you very much for listening to me. Remember that the PhD students are the people you should wake up for now. This is the moment.